Hello, my dear student. Today I am going to discuss about Edexcel IGCSE Certificate in Physics, Unit-3, Chapter-3, Light Waves. Edexcel IGCSE Physics pages 113 to 122. Content applying to triple science only is shown in the red type on the next slide and is indicated on the subsequent slides by triple only. I am Jahangir Alam. I am a physics teacher. Edexcel specification for this chapter. First, we have to learn about what is light. What is light? Light is an electromagnetic radiation. Technically, light is the part of electromagnetic radiation that humans and other animals see. Although incorrect, we usually call light all types of electromagnetic radiation like X-ray light, ultraviolet light, but it is incorrect. Light is made of energy. Light always travel at the speed of light, c 3 into 10 to the power 8 meter per second through vacuum or free space. Light is a wave. Light waves. Light is an electromagnetic wave. An electromagnetic wave is the transverse wave, that is the transfer of electric and magnetic energy. The two field, electric and magnetic field, vibrate at right angles to each other. An electromagnetic wave is made up of vibrating electric and magnetic fields that move through empty space, vacuum, or a medium matter, solid, liquid, gas at a speed of light about 3 into 10 to the power 8 meter per second. The energy that electromagnetic waves transfer is called electromagnetic radiation. Look at the diagram here. Here electric and magnetic field are mutually perpendicular to the direction of propagation of the electromagnetic wave. Reflection of light. What is reflection of light? Reflection is the bouncing back of a wave when it hits a surface or a boundary that is hard enough that it cannot travel through. Example, water wave bouncing off a board, image in a mirror, and glass or very still water echoes. Light obeys laws of reflection. What is laws of reflection? There are two laws of reflection of light. First law of reflection states that the incident ray, reflected ray, and the normal all lie on the same plane. Second law of reflection of light states that the angle of incident I is equal to the angle of reflection. Look at the diagram here. So incident ray, reflected ray, and normal drawn at the point of incident with the reflecting surface all lie on a same plane. Here same plane means the surface which is vertical to the reflecting surface at the point of incident, where incident ray, normal, and reflected ray all lie on a same plane. Second law, angle of incident I equal to angle of reflection R. There are two types of reflection. One, regular reflection, irregular reflection. Regular reflection, if the parallel beam of light incident on a reflecting surface in such a way that all reflected rays are also parallel to each other, such a reflection is known as regular reflection. On the other hand, irregular reflection, if the parallel beam of light fall on a rough surface or irregular surface, then reflected rays is scattered in all directions. Such type of reflection is called irregular reflection or diffuse reflection or scattered reflection. Regular reflection occurs only if the rays are falling on a highly smooth polished plane surface like plane mirror. On the other hand, irregular reflection, it occurs if the rays are falling on a rough surface. This type of reflection enables us to see the object around us. Image formed by a plane mirror. Look at the diagram. This one is a plane mirror, and this one is the object which is in front of the plane mirror. Light incident on a point of incident on a mirror, plane mirror, and it reflects back with an angle of a reflection which is exactly equal to the angle of incident. uh, the light incident another point on the plane mirror, it also reflect back, but they do not meet at a second point, so we extend it, and then extended lines meet at a second point. So it is seems to us light emerges from this second point, that's why it is a virtual image. The image produced by the plane mirror is the same size as the object, so the size of the image will be same size as the object. The same distance behind the mirror as the object is in front. Remember, in a plane mirror, the same distance behind the mirror as the object is in front. Upright, the same way up as the object. Back to front compared with the object, that means lateral inversion occurs, and the image will be virtual one. Virtual, what is virtual? Difference between real image and virtual image. Real image and virtual image. First we have to learn about what is image. When a reflected or refracted ray meet at a second point, or it seems to us it appears from or diverges or converts from a second point, then this second point is known as image of the first point. So there are two types of image, real image and virtual image. Real image is the image which is formed when the light rays meet at a particular point after a reflection from the mirror. Virtual image. Virtual image refers to the image which forms when the light rays appear to meet at different point after reflection or refraction from the mirror or any type of lens. Image type: virtual and real image. So virtual image, an image formed from light rays that actually diverges but seems to converge it extended. All virtual images are erect. Virtual image cannot be projected on the screen. On the other hand, real image and an image formed from the light rays that actually converts to form the image. All real images are inverted. Real image can be projected on a screen. Look at the diagram here. It is a virtual image. Virtual images are formed while light rays only appear to come from. A virtual image cannot be cast onto a screen. The image formed by the projector is known as real image because the light rays travel to it. Choose appropriate words to fill in the gaps below. There are 7 word selection here. The law of reflection states that angle of reflection is always dash to angle of incidence, equal to angle of incidence. Both angles are measured relative to the normal. A line that is at 90 degree to the reflecting surface at the point of reflection. A plane mirror forms a virtual image which is unlike a real image in that it cannot be cast onto a screen. The image in a plane mirror also the same size, the same way up as the object. Light refraction or refraction of light. What is refraction of light? Look at the diagram here. In the first diagram, light passes from air to glass. When light passes from air to glass obliquely, then it bends towards the normal. On the other hand, when light passes from glass to air, then it bends away from the normal. So what is refraction of light? When a ray of light travels obliquely from one transparent medium to another transparent medium, the bending of ray of light at the surface of separation of the two media is called refraction of light. So refraction is the bending of light when it travels from one transparent medium to another transparent medium obliquely. Then the light ray changes its direction of path. This phenomenon is known as refraction of light. Here AB in the first diagram, AB is the incident ray, BC is the refracted ray, and NBN normal drawn at the point of incident with the separation line. In the second diagram, I is the angle of incident and R is the refracted angle, incident angle and refracted angle. Laws of refraction. First law, the incident ray normal drawn at the point of incident on the surface of separation and the refracted ray all lie on a same plane. Second law, when light enters obliquely to a transparent medium from another transparent medium, then for a fixed pair of media and for a fixed color of light, the ratio of sine of angle of incident to the sine of angle of refraction always remains constant. This law also known as Snell's law. What causes refraction? Light travel at different speed in different media. Light travels at different speed in different media. For example, in air, its speed is about 3 into 10 to the power 8 meter per second, while in glass it is 2 into 10 to the power 8 meter per second. At the boundary of the two mediums, such as air and glass, there is a sudden change in speed of light. This change in speed causes the path of the light to bend, resulting in refraction. Remember, refractive index. What is refractive index? When a light ray enters obliquely to a transparent medium from another transparent medium, then for a fixed pair of media and for a fixed color of light, the ratio of the sine of angle of incident to the sine of angle of refraction always remains constant. This constant is called refractive index. Look at the diagram. Here light passes from A medium to B medium. So if the ray of light enters in the medium B from medium A, then the refractive index of medium B with respect to A is A eta B, sin I by sin R. Here I is the angle of incidence and R is the angle of refraction. A eta B, the refractive index of B with respect to A. Refractive index A eta B, that means refractive index of B with respect to A. On the other hand, B eta A, refractive index of A with respect to B. There is a relation or formula B eta A equals to 1 divided by A eta B. Reversely, A eta B equals to 1 divided by B eta A. Relation between refractive index and velocity of the light. A eta B, velocity of light in medium A divided by velocity of light in medium B. Zero eta B, velocity of light in vacuum divided by velocity of light in medium B. Refraction occurs when a wave changes speed as it passes from one region to another region. The speed change usually causes the wave to change the direction. Water waves slow down as they pass over from deeper to a shallower region. Light slows down as it passes from air into glass, perspex or water. Diffraction experiment. Remember, no deviation or no refraction occurs when the angle of incidence is 0. Increasing the angle of incidence, increasing the deviation. Refraction of light at a plane surface. When light passes from a rarer medium to a denser medium, then it bends towards the normal. Then angle of incidence is greater than angle of refraction. Here, look at the diagram. Light bends towards the normal. The angle of refraction is less than the angle of incidence. More to less optical dense transition. That means when light passes from a denser medium to a rarer medium. When light ray passes from denser medium to rarer medium, it bends away from the normal. That means it goes away from the normal. Light bends away from the normal. The angle of refraction is greater than the angle of incidence. Why pool appears shallow? Look at the diagram. Object at the bottom of a pool. Light goes from water to air medium. Then it goes away from the normal. An observer observes this refracted ray. Then it seems to him. It appears from as another point, second point. Then there produces an virtual image, a virtual image. Refraction equation. When light ray passes from one medium to another medium, then refractive index eta equal to sin I by sin r, where I is the angle of incidence in the first medium and r is the angle of refraction in the second medium. Eta is the constant number called refractive index. An experiment to find out the refractive index eta of glass. Set up the equipment as shown in the diagram opposite. For an initial angle of incidence I of 30 degree, trace the path of the light ray. Measure the angle of refraction. Calculate the refractive index using the formula eta equals to sin I by sin r. Repeat for a range of angles between 10 to 80 degree. Calculate the average value of eta, refractive index. Question number 1. Calculate the refractive index when the light ray passes from air to glass if the angle of incidence is 30 degree and the angle of refraction is 19 degree. We know refractive index eta equal to sin I by sin r. Here I is that I equal to 30 degree and angle of refraction r equal to 19 degree. So sin 30 degree divided by sin 19 degree. So 0.5 divided by 0.326. So refractive index eta for this situation 1.53. Question number 2. Calculate the angle of refraction when light ray passes from air to perspex if the angle of incidence is 50 degree and refractive index is eta equal to 1.5. We know refractive index eta equal to sin I by sin r. So 1.50 equal to sin 50 degree divided by sin r. We have to find out the angle of refraction. So sin r equal to sin 50 degree divided by 1.50. So 0.766 divided by 1.50. So sine r equal to 0.511. So r equal to sine inverse 0.511. So 30.7 degree. So angle of refraction here 30.7 degree. Question number 3. Calculate the angle of incidence when the light ray passes from a air to water if the angle of refraction is 20 degree and the refractive index eta 1.33. Eta equals to sine I by sine r. 1.33 equal to sine I divided by sine 20 degree. Sine I equals to 1.33 into sine 20 degree. So sine I equal to 0.455. So angle of incidence equal to 27.1 degree. Try to solve this one. In first case, first medium 1 and medium 2. Medium 1 is air and medium 2 is water. Diffractive index for water with respect to air is 1.33. So angle of incidence 50 degree. We have to find out the angle of refraction. In second case, light passes from glass to air. That means medium 1 is glass and medium 2 is air. Refractive index here 0.67. Here angle of incidence 30 degree. We have to find out the angle of refraction. In third case, light passes from water to glass. Here refractive index 1.13. We have to find out the angle of incidence and angle of refraction 50 degree here. Dispersion. Dispersion occurs when a prism split the color of white light into the spectrum. So when a white light passes from a prism, then different colored light refracts different. That's why dispersion occurs. This occurs because the refractive index of the glass or perspex of the prism varies with the color of the spectrum that make up the white light. Violet has the greatest refractive index and therefore deviates the most. Red has the lowest and deviates the least. Prism, white light incident obliquely on the prism surface. Then different colored light refract different. Then seven colored lights segmented separately. This is called dispersion. Choose appropriate words to fill in the gaps below. Refraction occurs when a wave changes speed as it crosses the boundary between two regions. The dash of the waves also usually changes direction. Light rays deviate towards the normal when they pass from a less dense air to more dense perspex. The greater the angle of incidence, the greater is the deviation. Different dash color of light deviate by different amount. Violet deviates most. A prism can be used to split the color of white light into a spectrum. This is called dispersion. Critical angle. What is critical angle? The angle of incidence in a denser medium for which the angle of refraction becoming 90 degrees is called the critical angle. That means when light passes from denser medium to rarer medium, for a certain angle of incidence, the angle of refraction becomes 90 degrees. Then that angle of incidence in the denser medium is called critical angle. Total internal reflection. If the angle of incidence in the denser medium is greater than the critical angle, then incident ray of light will be totally reflected in the denser medium. In this case, no refracted ray can be observed. In this situation, the separating surface of the surface medium behave like mirror. This phenomenon is called total internal reflection.